In this very short video, I just wanted to show you two different ways you can show that a quadratic is always positive for all values of x. So if we first think about what a positive quadratic would look like at all points, it would always be above the x-axis, and it also wouldn't intersect the x-axis at all, because we know it starts to be negative when it's intersecting the x-axis and it starts to go below the x-axis. So one way you can show that it's always positive is you can find the discriminant, which is b squared minus 4ac. Now if you're unsure what that is, all quadratics are in the form ax squared plus bx plus c, where a is the coefficient, the number before x squared, b is the coefficient of x, c is that constant at the end. So in this case, a is going to be equal to 1, b is the number before x, which is minus 8, and c is going to be equal to 17. Using that, we can import them into the discriminant equation and set the discriminant as being less than 0. Because if we show that the quadratic doesn't even intersect the x-axis once, that means it's always going to be above the x-axis. So let's do that. Minus 8 all squared would represent b squared minus 4. And notice I like to put everything in brackets because different calculators interpret numbers in different ways. And then multiplied by a, multiplied by c, which is 17. If we calculate the value of this, minus 8 all squared is 64. Be careful of the minus because we're doing minus 8 times minus 8, which then gives positive 64. Take away 4 times 1 times 17 is going to be equal to 68. And what we see is that it's actually equal to minus 4, which is less than 0. That means that this quadratic does not cross the x-axis at all because there's no roots. That's what's meant when the discriminant is less than 0. Sorry, I don't know why I'm stumbling over my words so much in this video. Another way you can show that it's greater than 0 is you can complete the square. If you complete the square and show that the minimum point of the quadratic is above the x-axis, then that means all other coordinates have to be above the x-axis as well. So in this case, when we complete the square, we have the coefficient of x, so half of minus 8 is minus 4. You put that in a bracket, all squared. Now when you square a bracket, that's the same as multiplying the bracket by itself. So we can write this as x minus 4, x minus 4. X times x is x squared, x times minus 4 is minus 4x, and this gives you another minus 4x, so they combine to give minus 8x. Minus 4 times minus 4 is plus 16. So this is what we currently have, and we want to get to x squared minus 8x plus 17. To get from where we are to where we need to go, we need to add another 1. Is all greater than 0. Now to find the minimum point here, what you do is, well, the x coordinate of the minimum point is the inverse, or it's essentially the x value that makes this bracket equal to 0. In this case, that's a positive 4. The y coordinate of the turning point is just this constant at the end. That's a positive 1. Now that we've shown that the quadratic's minimum point is 4, 1, all other points have to be above it. So it's always going to be above the x-axis, and once again, the y coordinate will always be positive. That's how you can show two different ways of a quadratic being greater than 0. Of course, in an exam, you'd only need to show one of them. Be sure to like the video if this helped and subscribe. I appreciate it a lot. Thanks for watching. I hope this video helped. If you have any tutoring inquiries, be sure to visit my website www.excellineducation.co.uk. It's on the first link in the description too.